Recording is in progress. Good evening, y'all. This is Platoon. Evenings, weekends. This is Hotel Platoon. Week 5, day 2. We're going to talk a little bit more about class inheritance. A little bit of review, a little bit of some new weird stuff, like these static methods. And we're kind of doing like a little bit of a video game, kind of. Kids love that, right? Video game development is probably one of the last things I'd ever want to do. Building games is not fun. It's not fun at all. Designing games is fun. Building them, not so fun. Nah, it's the same problem. You're not solving very fun problems, in my opinion. But I don't know everything. Some people will disagree with me. Class inheritance. Today, we have been hired by a video game developer to help them create their latest medieval fighting games. It's very simple. It's going to make Pokemon look complicated. They have some code from a previous game with classes for knights, offense, defense, but they want you to expand their classes to include 2 types of attacks, ranged and melee. Fun. Let's just copy this sucker down. Python knights.py. Sure. Oh, wait, not Python. Code knights.py. There we go. Paste. From random. There's random again. We were just talking about random. It's got a choices sub library, subtext. I forget what it's called. Submodule. We've got a class here, the offensive system. It needs a weapon. It makes an attack. All it does is it prints. Man, they're not going to be happy when we tell them that they need to return things. You can't just print. They've got a defensive system. Static method. All right, we'll ignore that. Block, blocking attack. Static method. Dodge, dodging attack. Makes sense to me. Engage defense. Some probability here. Do a block. There's some choices. True or false. You can weight those choices. We are going to have to read this library if we really care enough to figure this out. But it looks to me like they're doing some math. And it's basically a probability. It might block. And if it does block or dodge, it runs these other methods. Sounds great, right? We do some probability here. And then we either block or dodge, or maybe get hit. We really covered getting hit. That's a little bit more complicated. This is pretty easy to understand, though, I think. We all know what a knight is. He's got some offense. He's got some defense. All right. He's got 2 functions here, attack and defend. That's all they need to do. That's all knights are. They attack and defend. Seems good. And then if I run this, oh, look at that. It spits some stuff out. So we instantiate a knight, we make him attack, and we make him defend, and we make him defend. Is it always going to be the same? Oh, look at that. First one was actually the good one. So he attacked, and then when asked to defend, he dodged, and then he blocked. We ran it again. He dodged and he dodged. Blocked and he blocked, blocked and he dodged. So there's some kind of randomness going on here. That's good. In games of dice, which is all these are under the hood, is all Dungeons and Dragons under the hood, every game you've ever played. That's what we're doing here. We're just rolling some dice. Make sense? Does everyone understand everything? That's right. You don't, because I didn't tell you what this was. But VS Code might. Very helpful VS Code. Convert a function to be a static method. A static method does not receive an implicit first argument to declare a static method, yada, yada. It can either be, this is not quite the explanation I was hoping for. A static method is a method you can call from a class, and it doesn't have any idea about anything beyond that class. It doesn't know about instance variables. It doesn't know about class variables. Does that look like a thumbs up zoom? Um, it's a, there's words for that in other languages. What do you call that? Why is my brain not working? Well, I've just been looking at code for 12 hours. It doesn't matter. Somebody save me though. Man. Anyhow, it's a function that's random, right? It doesn't belong to this class. You can use the class to invoke it, uh, but it doesn't really refer to the class. It doesn't have any working knowledge of the class it's from. It is just a function you can call from the class. Cisco, I know you want to answer, but your mic isn't cutting in, I think. I'm going to think of it. I, I bet I think of it before you get that fixed. An anonymous function. Is that what I was trying to say? Is that what you were? I'm going to call it an anonymous function. Um, cool. Looks good. Why are we using these here? We're not really getting much out of this here, but the reason it is anonymous is these don't really care about any variables within this class. To dodge and to block, it doesn't matter what the weapon is. It doesn't matter of any other class variables that might exist. This is just the defense system. I want to use it all the time. I don't need to instantiate the offensive system every time. I could just call it like we do here. Notice, oh, yeah, you know what? We'll probably get away with doing it. We're not going to run down the rabbit hole. Um, oh, shoot, am I losing my mind a little bit? Oh, yeah, engage defense probability. Yeah. That's self dodge. Now I'm losing my mind. We always have access to it because we know the name of the class. It doesn't have any variables, any knowledge of that class. Doesn't need to. It is a anonymous function we're just using. Let's continue before I get down in the weeds too far and can't get it back. Let's add some ranged and melee weapon classes. Developers want your weapons, your weapon classes, to have weapon names and attack functions. As we have now, weapon is hard-coded and it's just a string. That's not very fun. I mean, what I want to do is build out weapon classes and put stats on them, but we're not having that much fun today. We are just going to have a melee offense and ranged offense. So let's copy over the offensive system. How about that? There we go. I didn't do magic there. I just pasted over the offensive system because we're going to have a melee offense and a ranged offense now. Still, I see some similarities here. You instantiate with a weapon. The only difference is here. Make attack, print, attacking with X weapon from really close because it's melee. Or you didn't see my self weapon coming, which is just another string, but it's going to be a ranged weapon because it's a ranged attack. Note, melee offense, ranged offense, offensive systems all have that weapon property. And that melee offense's make attack is almost identical to the offensive system entirely. Also, melee offense, ranged offense are types of offensive systems. So it'd be natural for those to inherit. So I copy and pasted because they were so stinking similar. We could probably use both. So let's put that offensive system back in here that I shouldn't have copied over. I got ahead of myself. I got so excited to cover the lecture or to cover the assignment that I probably should have reviewed this once more. That's all right. There we go. Offensive system, melee offense, ranged offense. They inherit from the offensive system, right? and they do this. What is this? I've never talked about this with you guys. What is this? Art?
Yeah, I believe that's just bringing all the assets in from the the parent class.
Oh, okay.
Well, actually, you know what? Correct me if I'm wrong, but something that's kind of interesting is that it doesn't necessarily inherit on its own. So if you were to leave that super in it blank, it really does nothing. It's just almost like a what's the word I'm looking for? Like a means. It's a means for you to provide information or provide those
A
assets.
bridge, you might even say.
Yeah, I like that. And I agree. And something that some questioning or quirky or just from other language kind of students will point out is like, hey, I could probably just instantiate it here and pull this in. I don't need this super in it. And the answer is you can replicate some of the stuff that's going on here yourself. Um, this is what Python suggests. This is what Python provides, and this is what it supports. So this is how Python suggests we inherit from other classes. And you're right. We have to give it. Sometimes we don't want to inherit everything. Maybe we would, maybe we wouldn't. I don't know. That I'm trying to think of a good instance where we'd want to do that. I almost all the time, forever and always, will want to take in all of its inherited values. It gets a little less dry when we do it this way, but we could use quarks and probably get around that. Um, but yeah, we're just instantiating it with values from the above. And that prevents us from having to type out self.weapon each and every time. We just instead have to type this out for each inheritance. Um, cool beans. All right, now we got the full code here. And that's where it just drops us off. But let's look at it. Oh, wait, let me copy paste. Yeah. Does this not have range attacks built into it? It doesn't. All right. We've added some code. We changed some stuff. Let's rerun. Make sure we didn't break it. Oh. Looks good. It's still working. But we're really only testing the same stuff we've already had working before. The offensive system. Is it really any different? Knight, offensive system, sword. I think I need to. That's right. Man, I do not like this lecture, just gives you so much to bring over. The differences are now that we've set this melee offense, we should be using that instead of the offensive system, right? There we go. So now we are inheriting from the offensive system this melee offense bit. I think we're still working here. And now we do see some changes. Cool beans. So we're attacking with a sword from really close. Make attack with the melee offense system from really close. Only prints that bit there. As we saw earlier, what we were going for is we had two different outputs of text. What's that? There we go. We want to show what weapon we were attacking with, and we want to say something about the distance or the weapon we were attacking with from some other distance. Doing it this way, the offensive system is always going to tell us what weapon we are using to attack, and then whether it is a melee offense or ranged offense, it'll then add the next bit. Because our knight only attacks with the sword ever, it's always going to say attacking with a sword from really close. Let's make something else. nights are fun. What else do we want to play with? What's the next archetype we're going to build out here?
Make a ranger.
All right, you make a ranger. What do I type next?
Oh, I'm still muted. Okay, class ranger, then def init self.
Done.
Oh, that's fancy.
What
Then
next?
let's do the self.offensive and then melee offensive. And then within that, the parameter there, add dual scimitars.
All right, I like where your head's at, but can we use the ranged offense uh,
Okay.
class, please? I understand rangers can do both.
Okay, then a longbow
All right,
for him with oh no, it has to be is there a ranged offensive? I think yeah, there is.
there is. We created that up here. Remember, ranged offense. We just haven't tested it. Ranged offense, melee offense. So longbow. I don't know if I need to capitalize that. Anything else? We probably just bring everything else over here, right? And already we're seeing duplicated code here. Oh, okay. So we had to kind of duplicate all this bit here. What we probably should do at this point, since we've got two different classes of whatever you want to call them, the archetypes, probably could have class anything, person, character, what have you, maybe adventurer, right? Something like that. Because they're always going to have an attack and they're always going to have a defend. And we could just bring that over, right? What's going on over here? I don't even know what y'all are out nerding me. Um, let's leave this hanging for now. But yeah, Ranger, ranged offense, longbow. We probably could have saved ourselves some time and just said, oh yeah, hey, this knight, by the way, it has a longbow now. Um, run. There we go. Separate that out a little bit. There we go. Now we see it in action. We've got knight attacking with a sword. We've got ranger attacking with a longbow. We have used inheritance to save ourselves a little bit of work. And then we immediately noticed, hey, we've got duplicated code. So we could create an adventurer that always has this attack and defend that we can refer back to. And this is why I don't like building video games. Because real quick, and if you do something like this, which this can be fun and this can be interesting, and if you're, you know, I don't want to go down this rabbit hole too far. When you're working in this class, when you're doing really anything, you're learning something new with coding. These lectures are designed to, uh, you know, give you a new topic, or give you something similar, add a few new things, give you some interesting assignment, or something to talk about while we do this, and hopefully, it's enough for you to be interested in to stretch out that new skill and learn it. You will never retain half as much as you would have is if you're kind of just building something that you would like to build. Um, I like the addition of these kind of things in our lectures because somebody's brain always just lights on fire during one of these sort of video gamey lectures. Even though this is not very complicated, this is not any more fun than anything we've done. I just put the word knight and weapon in it, and already we always have people who are like, "Oh my God, wow!" Uh, all that to say, build something you're interested in if it, intrigues you. I know some students, we got to this point in the class and they were jacking with this most of the rest of the class, incorporating stuff we had learned. And that's great. I would love if I could get everyone to just start a project and continually reiterate on it over and over every time we do something. But ultimately, I know that's not a good thing to do because you're going to be building on top of crap. Uh, as we give you more and better tools, you do all this, you write all these classes out, and then we teach you about databases, and you're like, oh, all this code has to go away. Or we teach you about Django, and it's like, oh man, yeah, I could have made this a lot easier. Um, didn't add too much today. The only thing we really have not seen before are these static methods, which, as I explained, this is a method that can be called without creating an instance of its class because it doesn't really know anything about the class. That's just saying, hey, I can use that offensive system and I don't need to create one each and every time. I think I can display that. In fact, yeah, I don't think that is necessary. I hate going off the rails during class when I'm recording myself, but let's learn together. I think that should work. Oh, did I misspell it? Oh, it's not working the way I want it to. I don't think, oh, that's probably because we're not using it properly. That ought to work, maybe. Offense, does it not? Oh, am I going crazy? I'm not crazy. There we go. Geez Louise. That's all I wanted to show. That's what the power of a static method is. We show in the lecture static methods, and then we don't really talk about them again. What the heck did I do? Someone explain to me what I've done here with these comments. Who follows that? It's okay if you don't. This is very ephemeral and abstract, but it's important. What do I do on this line, Nicole? 44.
You just took away the
Don't look at the comment. What if that was the real code? What is this line doing?
you're pulling in the class melee offense to be self.offense and assigning
I
it word.
Yeah, but okay, what am I doing here?
You're creating an instance of knight.
Yes, I am creating an instance. I'm instantiating. So, what am I doing? Just say it again. What am I doing on this line?
You're creating an instance
I sure
of
am.
melee offense.
I am. I created an instance. Pulling it in, setting it as a variable, all true, but let's not lose track of what we're doing here. I'm creating an instance here. This is composition. I just pulled in some class. I set an instance of it, and I said that instance is equal to offense. I don't have to do that if it's a static method because I don't need an instance of it at all. So this is what we were doing. What were we doing here, Joe?
You were doing the same thing. You were making an instance, so you got rid of it.
Untrue. What am I doing on line 48? I don't see an instance being created.
Oh, sorry, you got rid of, you don't have the equal sign there, so you did not create an instance.
What did I do? What is that line doing?
Um, you're that's a method for make attack.
Yes, I'm just running a function from that instance, right? I'm I'm picking out that offense, that instance right here. To ignore all this, this self nonsense. I'm just using that instance and I'm referring to one of its values, one of its methods that make attack. I don't need to refer to that instance at all. I can get rid of all that and I add this line instead. So instead of here where I instantiate and then refer to that instance, I can just say with a static method, hey, just use melee offense. All the time, it's going to be okay. My knight only has melee offense. I don't need to build a nonsensical variable here. I don't need to refer to that instance. I can just use this melee offense class to make an attack. I don't have to create something every time I want to use it. These classes exist, and with a static method, I don't need to instantiate them. This is another way to kind of use, classes. We get our heads real caught up into when we're building out classes, we need to instantiate, we need to create an instance of it, and we refer to that instance, and it's a living, breathing thing. Well, it doesn't have to be. It's just another way to organize code. We can use a static method, and it's ephemeral. We don't have to stand it up. I don't want to have to create a knight and create the offensive class and create the defensive class, which, by the way, are inherited. And I need to create a weapon, so I need to make another instance of the weapon. Like, I can if I want to, but this is all I really need to do. I just say, hey, go make a melee attack. Because this class up here could get real complicated real quick, right? As soon as I start adding stuff to swords, as soon as I start saying, like, is that the bronze sword or the steel sword or the whatever? Oh, by the way, I need classes for all these different damage types. What about critical chances? I need to add that as another feature in here. That might be its own class. Goodness, is it one-handed, two-handed? We've got a whole thing. This melee offense is about to get real complicated. This could get real complicated. The whole offensive system could get reworked. I ain't changing squat on this code here. It's always going to be this. That's dry. That's the point of dry. It's not to save lines. It's not to make it look clean. It's so that we don't have to make changes in more than one spot. And that's why static methods could be useful. Are y'all picking up what I'm putting down? How often do I use static methods, you may ask? Not very. I just don't write a lot of code that uses that. Not to say, just within the last 2 months, I've approved a PR that's had a static method of a class in Python. They do exist. Depends on when and where you see them. It's all your code and your design. You could accomplish this without a static method. Obviously, we did it just there. I had to delete 2 lines. It's all tools to help you organize and help you build stuff bigger. But that's all I really want to throw at you today. It's pretty much just class inheritance review. We didn't really do anything new, except for this. I'm not going to go into this library because I don't think it's worth our time. I'm not going to teach you every Python library. If you thought that's what we were going to do in this class was to cover every Python library ever, no, that's silly. If somebody really wants to dig into this, we can. I'll tell you, you give it options, you set a probability, we subtract from that probability from 1. And depending on how many times we want to run, it's going to give us a list. We're taking the first one of that list. That's how we get that true and false, block if true, dodge if false, whatever you want to call it. Don't worry too much about it. You can learn more on your own if you want, but I'm not teaching about the choices sub-module today. Your challenges, plural, today, ice cream and freezers. Very similar to apple trees. Very similar to apple trees, I would say. We're just going to have variables that are going to get kind of updated. You can have a runner for this that runs through and iterates and says, an hour went by. Is the ice cream good? No. An hour went by. Is the ice cream good? It's good. It's burned now. You can do a script like that if you want to, if you think that's useful. Or if you have an easier time wrapping your head around tests, no tests, you can create your own. Sure is handy when we provide those, but also it's good to get in the habit of writing your own tests. If you don't know how to write a test, look back at your assignment from yesterday. You could copy paste that entire file and just make changes to it. That's what a lot of coding is anyways. I would prefer you to do that over not writing tests. Or having ChatGPT write them up for you. I would like you to just copy paste something old and retrofit it. You'll learn more that way. Questions, comments, concerns?
Is that ice cream challenge or assignment going to have to use that static method?
Want to. Doesn't have to.